Everyone, a very warm welcome to today's webinar on Azure AI Agent Hands-on. Fine-tuning LLM1B for production-ready fast API code generation. My name is Ankita, and I will be your moderator for today's session. And I represent SpringPeople, India's largest leading enterprise training provider, and we are delighted for to have such a strong audience joining us for this practical and highly relevant topic. Now, before we come to the topic, let me introduce SpringPeople. Uh, SpringPeople is India's leading enterprise training provider, and we are delighted to see such a strong turnout this time. Our portfolio includes over 3,000 instructor-led technology courses delivered by more than 4,500 industry experts. These cover areas like AI, machine learning, cloud, data science, DevOps, backend engineering, and more. Everything we offer is built with one simple focus, helping learners like you apply what they learn directly in real projects and real jobs. Now, coming to today's topics, most of us here have probably tried using general LMS for coding or backend work. They are useful, but they often fall short when it comes to specific frameworks, real projects, patterns, or production workflow. In today's session, we'll look at how a mid-size 1B parameter model can be fine-tuned specifically for fast API and backend use cases. And to guide us through this journey, we are happy to welcome our speaker for today, Mr. Rajeev Chandran. Mr. Rajiv has close to 20 years of experience working across product engineering, data platforms, and ML-driven systems. His work span across data engineering, ML engineering, search clouds, and DevOps. And he has built large-scale systems across industries like e-commerce, retail, search, and advertising. Now, what makes Rajiv's session especially useful is that he connects model level decisions with how things actually work in production. We are so glad to have with us today. Now, before we begin, just a couple of quick housekeeping notes. All participations will be on mute during the session to avoid any background noise. During the Q&A session, we are welcome to raise your hand and will unmute you so you can ask your questions or seek clarity on any part of the session. You can also post your questions or queries anytime during the session in the question box, and Mr. Rajiv will address them towards the end. With that, let's get started. Over to you, Mr. Rajiv.
Thank you, Ankita. Extending a warm welcome to all for the session on this fine session on how to fine tune a small model. Basically, this is what I'm presenting today is an effort to build a model where, though not tuned for coding, how we could fine tune it and get it ready for custom, as a custom model with your own set of corporate code, which is largely never exposed. So to that extent, it's an effort to see why we want to do this, and why did we even choose a small model to get this going, and to see whether these small models are effective itself to generate code which are of production quality. Okay, so just getting into a little into the basics. So why we need to fine tune? Because basically three reasons. Prompting doesn't solve what we intend to. While RAG, retrieval, augment, and generate do not change model behavior. So only a fine tuning basically does change the behavior of the model. So that's why we have to fine tune. So there is always a need to fine tune, and we will see as we go to the rest of the slides as to why we have reached here, and Otherwise, why we could have solved this problem using a prompt engineering technique or a RAG technique. Okay, so um, while it's an experience for all that when you're using large language models, that you could use any kind of prompting techniques and pretty much get the results that you are looking for. Right? That's a given. But what we don't realize is if you're going to use small models, uh, prompting is of no great help. You can try it in any kind of combination, but it will nowhere reach your desired results. And much like that, even if you take a large language model where which does not have the context of your specific standards that you fall in your organization, even the large language model also would not have that. So any kind of prompting techniques would not lead you into any desired output that you were kind of thinking. um, so that's why you would at some point in time eventually get into a stage where you will have to do some fine tuning in some way or the other. And we'll see the different things that we have looked at. Okay, so uh, largely these prompting, RAG, and fine tuning. We There's always that assumption that if because you use so much the larger language models, you always overlook fine tuning, which is actually a very important part of the overall ecosystem. While prompting, as we just saw, for short-term controls or some variations which you do through persona change and things like that, it would help you to get some output. But after certain point in time, it just cannot go because it doesn't have that context at all. While RAG, the uh, uh, though no, I mean, see, you've used RAG in some form or the other, but what makes RAG important is it keeps your data relevant. Now, as an example, if I take a model that was, say, released in 2022 or so, and say I if or let's say, yeah, 2022 or so, and if I were to ask who's the president of US, it can never give you the right answer. It still points to the, and I mean, rather, if I use a 22 model and ask the query now, it'll point to the old day. So RAG is relevant. Is very important to keep the data relevant. Even though we can still work with the LLMs, but it is not easy to keep your LLM updated with the latest data. That's not a pretty easy task when you have a very large thing. So again, we look at it. While fine tuning, while prompt and RAG are probably small changes that you do, but the behavioral change will only come in fine tuning. Now, when I use the word behavioral change, it is that classic case of as an example to refer. While you know English, but do you know the vocabulary that's used, say, probably for research, or a vocabulary that's used in a finance world, or a vocabulary that's used in, say, a medical field? Now, that is fine tuning. Okay, so while it is generic, so that's a behavioral change where you can clearly discern that this model can speak the language that you're looking for, which cannot be done in much. Even in for a large language model, at certain point in time, uh, and if there is no context, it will not give you that behavioral change that you're looking for. Okay, so while each one is important, but it is eventually the fine tuning technique. So fine tuning technique is not to update with the latest data, but to make a big change in the way, or you are adding a persona to an existing model which otherwise has been missed out. Okay, hence you have to, at some point, any model will eventually go through a fine tuning process, while a model will continue to have its prompts, variations of its prompts, and definitely the rack, because that's the only way you keep the latest data. Like example, if I take a programming language, and your model is, say, uh, designed, like if I take Python as an example, which is what we actually, and this session is all about the FastAPI, which is the Python framework. And if there is a new version of FastAPI released, definitely the older models will not have a context, not context and the newer features. And it is not easy for the LLM to ideate on that new feature. While LLM is capable, large language, the larger models are supposed to be able to, ideate on a feature which it might not have been explicitly trained on. That's the other important aspects of the larger models, which the smaller models cannot really do. Okay, so what was the objective? And I mean, for this particular work was uh, uh, this piece of task that which I did, and then the seminar that we are doing is to fine tune a 1 billion parameter model. In this case, we used Llama, mm, to generate production ready fast API code. As if you are not aware, fast API is another framework, much like Node.js and Ruby on Rails, etc. Various types of frameworks that exist. And after tuning, we will also see the comparison and things. After tuning, we actually hit more than 90%. Actually, we hit nearly 100%, and it was able to, really train. It was able to really generate a, a great production ready code without being very expensive. It's I mean, when I say $10, it's per hour. Okay, and I didn't have to go through multiple hours overall. and and it did cover, you will actually, I'll show you when, how it used to generate the code without from a base model, and how it generated when it after it was being trained. Okay, and then why do we take 1 billion parameter model? So large, in most of these organizations, everybody wants to, or most today, any organization would want to keep these AI costs low. So there is always that intent to try to work with smaller models. But smaller model also has its the capacity problem. When I say what the capacity I meant is the cognitive capacity. Lower the model parameter, and then that abstract value, as you would call it, kind of reduces. So that always problem exists. But however, the interesting aspect of the smaller models is that uh, it is the greatest model to tune on very specific domain requirements. You really don't need a large model to do that. And that's why there is always that clamor to have 1 billion parameter tuned. I can fit this into my mobile to have it in the edge, while of course the bigger ones will always lay behind. Hence the reason. So it's from a cost perspective, training efficiency. You can get this at at even the worst level. You can finish your training in not more than a day or two, and it shouldn't cost. At a very high end, I would say not more than $10K when you're trying to do a fine tuning. But that's very rare. You always have it done under $500. That's the larger. Uh, and on another note, if you take anything less than 500, it becomes inefficient, in the sense the cognitive skill of the LLM goes away. The idea called abstraction, or the distributional hypothesis, which this whole LLMs are built, that goes away. So you can't take too small as well. And 1 MB, I mean, the 1B gives you, that sweet spot, to not too small, too big, and fit across devices. So that is one large intent of a lot of organizations. If I could pack everything within one model, I mean, everybody would be happy. So that's pretty much the ask for a lot of organizations, but may not be always possible with that stuff. Okay, so now understanding this Llama 1B model and on what it was trained on. So if you look at it, this was largely trained on blogs, tutorial, uh, code snippets, partial code snippets. So what you mean by that is, if I were to ask it generate a sort function, it will do like any sort, merge sort, or whatever the different kind of sorts, bubble sort, etc. It would very efficiently come out um, um, with the output. And that way, if you look, it should output. Most of these models would very efficiently handle programming languages like C and Node, which is vast. I mean, if you look at, if you kind of scale it, you'll find that probably Node is the most used. Node, PHP, and Python now, I think, will always be on the top category of. So when models are trained, you'll find uh, uh, wherever there is a large bias towards something, that always reflects in the model. That aside, yeah, it would be kind of trained on blogs, and most of these codes are largely GitHub and from various other sources, but never corporate. That's some point that you, because nobody exposes that, right? And then various blogs and markdowns. So that's how it is trained. So uh, this model is just not it's only not only a code packed, it also has general knowledge as well about from the data that it has been picked up. Now, while uh, contrasting that to what it does not have is, and it actually definitely shows up when you actually start looking at it, it would not have specifics of frameworks, like a Flask or a Django, or let's say even maybe tools like Ruby on Rails and things like. It's it produces only snippets of code, and it is not consistent, very random. So qualitatively, it is kind of really bad when you look at it. And it's bad because it's not trained on it. It's as simple as that. It's not bad because it is bad. It's just that what it has been exposed to as a part of training is what would help you to. So that way you look at it, Llama 1B is kind of a jack of all trades and master of none. And fails not because it is small, because it's very general to say. Hence, it's one a target model where you could fine tune it, and make it make it specific, and targeted towards your domain specific requirements. So here, what I did was to train this for FastAPI, so that it can generate code which has structure pretty much like your FastAPI. Okay, so coming to fine tuning technique, there are various kinds of fine tuning techniques that are prevalent. You have supervised fine tuning and domain adoption fine tuning, and there's the one which is used today pretty much is what we call as the partial fine tuning techniques, like the parameter efficient fine tuning. That's what it goes into. And then you also have these um, um, a feedback mechanism by a way of prompting the model, saying that, hey, like if a very way, a nice way of looking at it is, let's say you have multiple choices. I'm sure you must have seen this in chat gpt. um, when in chat gpt, when you would have noticed that it gives you two answers, and then it asks you which one do you prefer. So that's all form of reinforcement learning with the human feedback. And in that case, it was just asking you a choice which is better, but you could also give it an input saying that, hey, why you want to do this, this is a wrong way, it's a wrong approach, you may want to do it this way. So you could even modify the way its behavior itself is. So a fine tuning technique therefore combines multiple things, while overall very cost efficient, and it gives you the desired results. So very specifically, what I've used here is the technique called LoRA. There is LoRA, QLoRA adapters. Um, then there is prefix tunings and prompt tuning, various tunings that fine tunings that exist. And today the most popular in the industry is the LoRa fine tuning. So it is just not LoRa. If you look at from an industry perspective, it's a combination of things that they use. They would use supervised fine tuning with LoRa and adapter. LoRa, and there is this idea called adapter, so that you can have versions of training. So I can make a model have say, as an example, I can train a model for Python 3.10, 3.11, 3.12. So it's like having different adapters. And then you also put in the human the reinforcement human feedback stuff as well. So it's a combined stuff which eventually becomes the fine-tuned work, and then you go through all your testing phase to kind of understand that. Okay, so just to understand LoRa and QLoRa a little better, LoRa fine-tunes large models by learning small adapter weights while keeping the base model. So one of the important, when I say that if it's a parameter efficient fine-tuning, the base model weights are frozen, and it creates a separate block. It creates a separate block, much like if you've noticed what these transformer blocks look like, and which we call an adapter. And then that is attached to the existing weights as a part of a training. So what it gives you is, while it retains the old they retains the existing cognitive skills, and you add additional cognitive skills to the model. So that's way it is kind of be efficient. Uh, while the only difference between LoRa and QLoRa is you can reduce the quantization. Now, what that means is just to reduce the memory footprint. In the LoRa, if you look at the LoRa way of doing it, it keeps the floating point to that maximum number that it can. While in quantized, it just gets reduced. You can have a different 4-bit, or it reduces the floating point size of the embedding values, so that way it kind of keeps it within in memory and things like that. So having said that, yeah, the industry standard is to use LoRA for the fine-tuning stuffs. Okay, so now how do you fine-tune itself in the first place? Uh, the most important piece is you need your data. And where do you get your data? So now that's the important piece. And then that data has to be curated in a very specific way for the model to be fine-tuned. So that's that early piece for the fine-tuning process. And then, of course, you know what base models that you want to take. It could be anything. While, yeah, Llama was popular, but of course, there are many processes. And then you go through that iteration to do the tuning, and then you evaluate, and it gets into the deployment as the process. So the crux here is on how to get the right data. Right data is important, else you'll find a lot of yeah, you may want to call it hallucination, but it's not hallucinating because you just gave a set of data which is not aligned, and that's why it was hallucinating. Okay, so now let's look at the performance of the base model. When I say performance, we are evaluating this base model against code generation for FastAPI. That's what we are trying to tackle. Okay, so the base model, which is the Llamas 1B instruction model, uh, without fine tuning, achieve just 40% for a FastAPI tag. Uh, and and that's how it was. Okay, while the overall, I mean, even though it passed quite a few tests, but it doesn't mean it was nowhere reaching even leave alone production. Even at a basic developer level, environment, it wouldn't be suitable. And of course, the critical aspects, like various things, things like whatever here the using the I mean the database abstraction stuffs, or JOT, Java Web Tokens, query optimization, pagination. I mean, which are all the very critical aspects of the REST API. None of this actually really worked, and at all places, yeah, it had some idea, but never the full context on this stuff. Okay, now, yeah, how did I train this? Now that's the other interesting side, right? Uh, you we will struggle if you're trying to use this on your laptop. And then you can, this will definitely run on Google Colab. If you have Google Colab, it definitely runs on that. I've tested it, but I was very keen to know how it would actually run on on AWS, and using the GPU virtual machines from AWS. So that's what I used. I used a 16 GB, 16 GB RAM, and one GPU, just one GPU. Of course, it's no system comes with only GPU. It has its own set of CPUs as well. It had around, I think, 4 core CPUs. 4 or 8, I think it was. I don't remember fully, but yeah. So it'll have its CPU, and it'll have its a GPU. So for training, it will use the GPU, but everything is controlled, orchestrated by the CPU. And as the tuning mechanism, I use LoRa to do it. And yep, there were various optimizing techniques that I used to run this. This was I used PyTorch for this whole development. You can use any of things, either PyTorch or even NumPy, to get this going. And I use the Hugging Face instruct model to do it. You can basically take anything to actually run it, or even PyTunes, which is another way to fine tune, or Unsloth, that's another way to fine tune itself. But yes, I wanted to custom build it from grounds up, and I basically use the Hugging Face's model and its modules to build this whole stuff up. Okay, so now this is as an exercise. It's been a pretty long and many iterations to reach where it is, because that's the nature of training itself. So as I said, the first important piece is the data. Without the proper data, um, if you train it without the proper data, you will get, the output is definitely going to not match. So the data would appear. So what you will have to do is, uh, um, you will have to create a JSON file. So you'll have to create a instruction output pair mapping. So look, you don't. The question can arise is, should I use all variations or all combinations to get the output? No, that's not the idea of LLMs itself, isn't it? There is this idea of abstractions, much like, yeah, you feed it with something, and the rest it can ideate and generate new things which it has not been fed with, right? That's the other idea. So you will have to give it like in a JSON file, and the trick here is, so like, let's say, I want to make sure the ORMs, this is the ORM for Python, right? For Flask or otherwise generally. Now, when so I mean, so if I have to make sure, um, uh, get that output of this instruction correct, I will need to get those right set or a minimum set of the ORM combination, um, to uh, get that accuracy to 90% or thing. Uh, so if you look at the SQL Alchemy guide, you'll find the combinations are in thousands and thousands, right, or millions probably. Now you can't do that, but however, you can take a minimum certain set, much like, there is, everything has a very base set of anything. Like, if you take a programming language, it has its base set of data structures, its base set of other things for conditional expressions and loops. So if you teach a minimum of that, it can generate the code. Likewise, you will have to generate that minimum, and which is a pretty much a trial and error effort. There is really no right way to get this. So and this was generated. So I use synthetic, rather I wrote a code to generate the synthetic data. And one of the combination, it got it right. So that way. And if you look at it, if I just give you kind of a, so initially I had a very large set of combinations, of not this alone, not the ORM alone, but various other categories like probably jot and pagination and things like. And but it never gave me the results that you wanted. While those iterations went through many iterations, and you see that like at certain point, somewhere between version 5.2 and 5.8, I seem to have got that right mix in place. And eventually, when I kind of reached maybe like another 7 more iterations or 8 more, and with around 2000 odd examples. And then I use the word categories. These are all those different categories of a REST API framework to do various things. You pretty much your middleware is that you can think of it. And yep, with this combination, I seem to have hit the right results. So that way, data set strategy becomes important. Now, if on another note, if you look at if this data set were to be really really large, which is what, like the today most of the LLMs that you use in copilots and codexes and cursors and various other things, they are largely the 70 billion models. So what's interesting about the 70 billion model is that their cognitive abilities are better. Or what I meant is, even if I take a small set of data and train it, uh, by the nature of it being, or I would use the word a critical mass being there, it can ideate on stuff that I have not trained on. Okay, so that may not be always true with the small, but if the task is targeted, then this is the way to go about doing it. Okay, and pretty much training LLM is much like doing a training of any of your models. If you've gone through an ANN, CNN, RN, or a GNN, or even the existing machine learning models like whatever you've done through regression or XGBoost and stuffs like that, it's pretty much the same. So you'll have your epochs, your gradients, your batch sizes, all of that. You know, hyperparameters continue to exist. So those would be there, and all that you when you're training an LLM, the important piece is the memory, which you may not suffer that much with your other models. So you will have to you know uh, get your batch size correct. If not, you will end up with too many memory overflows. So that's something that you want to kind of take care of. So look, you can see here now what happened after I trained. See, with the base model, um, it was at this. After fine tuned, I could reach at this, and yeah, you could see so many tests passing. And the categories, when I meant categories, just to understand that it was all the whether it would generate the ORM correctly, whether it is able to use jot correctly, I mean the Java web tokens and things like that. How would it come up with the pagination, and how it would handle error handling and things like that, exception handling and stuff like that, that you would see this big change that is happening. And so when I use the word category, yes, it was all about how efficiently it would handle your CRUD operations, or FastAPI is an async. It's much like your Node.js, or rather, it is architecturally the same as Node.js, right? It is an event-driven loop through which, and it wouldn't generate that, or a query optimization and things like that. So after I fine tuned, you notice that I am able to reach most of it close to 100% accuracy, which otherwise in the base model was at very low levels. And by the time I hit the upper end, I could have I had 14 different categories and reaching nearly 100% in terms of its accuracy of the output that we had. Okay, so now the other way of looking at it, you notice that while the accuracies kept going up from that version 5.2 to certain versions, it actually dipped because I increased the categories from 5 to 8. So it is definitely a more broader coverage. So, and as usual, as I say, if you don't get your data sets right, though increasing the categories, of course, is a bigger load, it will dip the accuracy. But look at it, by the time I hit the version 15, uh, I had much more categories and almost hit a perfect 100. So that means any code that is generated for the fast APIs, I mean the framework, it was 100. So the core, like your CRUD, the typical CRUD operations, Alchemy and WebSockets, error handling, all of that core basics of any REST API framework, it it handled. And I keep emphasizing on this idea called abstractions, or learning what is not trained for them. It was able to handle middlewares, rate limiting, caching, uploading, request validation. Now, these were not very specifically taught, but the data set, uh, indirectly contained references to this, and it added that without me, without a focused training on this particular stuff. So this is what we actually call as abstraction, where you don't train for something specific, and it reaches, you get things which are not. Large language models, they are adapted it. Anything beyond 70 billion parameter, they are all absolutely efficient to do these kind of stuffs. Now, the other great advantage, I mean, the other great, advantage is when you're training programming languages, any programming languages, or for that matter, your SQLs and things, uh, the learning is very efficient. What I mean by that is, we are talking of a set of data that's been fed into LLM, which has a great structure already built into it. Mm. And the great part of a neural network is this ability to memorize the patterns, or get the patterns very quickly. So it's able to learn the structures. If it's a like if it's a CRUD operation, it knows how to. Okay, you just feed with one or two or three examples. It quickly is able to grasp that. Likewise, you give it, and then there are not too many variations, right? If you look at it, there are not too many variations. So you don't need like thousands of examples to be fed into it for it to understand, because programming language, a computer language, inherently come with a structure. Contrasting that to generic data, when if I'm training a model with some customer data of, say, example of an organization, and expecting that this will generalize with another organization, that is not really easy to get it. LLMs, as rather small language models. While large language models will of course be good at it, but they will never be precise. You take as an example, if I have to build HR chatbot, I mean, you really can't get the specifics of your organization unless you feed it with the HR policies of your organization. It largely give you, even though it's large model, it still gives you very specific data. So that's about the when you take any, the general languages that you used to the computer languages, which inherently have a structure which makes it pretty easy to learn. Okay, now take a look at the code quality comparison. So I gave create fast API post endpoint for a user creation. Now this is before fine tuning. Everything is missing out, right? In some cases, there are only just frameworks, skeletons put, and there is no validation. I mean, no duplicate checks, no error handling. There is nothing. But it still gave something out because of, as you know, it has been fed with some kind of a data while it was training. Now after training, it's like uh, it cleared everything. It literally cleared all the tests. I mean, if you come from, you will see that even the async has been captured. The construct, right, the async construct, to make it in the event loop form, that has been captured. Here it is not at all. As you see here, it has been there. And DB is just, it's only placeholders there, nothing more. While it is able to even put it into a transactional way. Mm. So it would have, it actually caught everything. And what was the number of samples that I gave? uh, it's around 2000 plus samples. Okay. And how are these samples? Yeah, you give an instruction as to what you want to get, and then I feed it with a full example of that, saying that, hey, if I get a query like this is my sample output going to be. And that is fine tuned. Okay, so you can see that qualitatively how much of it is different. Okay, so you notice, so the it's gone through kind of, as we've seen it, with starting with those 4,000 examples, and then going towards, yeah, I mean, up to 5 and up in 15, 18, 20. I know, I mean, there are many iterations that I have done. And as which, I mean, there's another point which I didn't highlight there, but hiding here, you when I say it 100 for those 14 category which I talked about, what was important in that is I kept my temperature. Right? The randomness can be controlled by temperature top P and top K. Uh, I I would notice that if I were to bring the temperature uh, to 0.3, that means making it more deterministic. I would really, I would hit nearly 100. If I were to keep this at a higher level, then I'm looking towards 90s or even below, uh, uh, than that. And 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 yes, so by then I could expand it from 5 to 8 to 14, and just expanded the categories with an absolute kind of a perfect optimized stuff. Do remember, I can't also keep expanding so much. uh, yes, you will hit the forgetfulness of the LLM, as they would say. Right? It because it can't hold that much more in the memory than otherwise it can. So the So the diminishing of memory is always an issue with the small language. So that's why it has to be very focused. See, now I'm not going to train this model with even say I want to add Django into it. Never. I will not do that. I will just leave it at just flash. I mean, with fast API, and that's about it. Because we definitely end up in those kind of spots. Okay, and you will have to do extensive evaluation and validation of the models. And yep, so went through various testing strategies, and this turned out to be the killer stuff, the temperature, where I was more deterministic, it became more predictive. And that sweet spot was 0.3. These are things that you kind of end up learning while you do these training stuffs. Okay, so having said so much of fine tuning, does it mean that you will do away with RAG or the prompt? Never, right? The best solution will always include fine tuning with RAG and the most optimized prompting technique. So that is not going to go away. So what does fine tuning? As you know, it would give you that behavioral architectural structures that are needed for the large, I mean, small language to know. RAG would not give you all that. Okay, but if you want to keep with the updated data, updated facts about that particular, then I can't do away with RAG. So it's so when you look at platforms like uh, um, GitHub Copilot, or I'm looking at very specifically the programming platforms, GitHub Copilot or Cursor, and Codex, various things. What you would notice is they are basically an agentic RAG. It's basically an agentic RAG with fine-tuned models for sure. And it won't be one model, right? There would be one model specifically catering to Python, another model specifically catering to Node, and it would be a kind of a graph structure, I should say, where, or a social kind of a structure where there are dependencies connected, and there would be an orchestrator, another LLM which is orchestrating the whole stuff. Where if a request is coming for a math query, I will not send that to a programming model. So in a large ecosystem like this, they'll have specific models created to keep the cost and things. So that would continue. So the RAG and the fine tuning with effective prompting techniques is what largely makes a AI platform. And we can't end with one fine tuning, right? So that's the other side of it. So much like if you come from a typical data science background, you've learned the art of training, right, and keeping versions. So that is also going to continue. So today you do this with the respective platforms. If it's AWS Bedrock and Azure Foundry, if it's Azure, and equivalent for Google. So you will have to build that framework where you continually update the model. So that work is not going to go away. It's you don't just consume models as is. It's I mean, not there is enough products where you consume as it is, but not always that way. So you'll end up you would have to create a pipeline of this, know how you create your data structures and stuffs like that. Okay, so that's all that I had. to talk on this, uh, kind of a POC that I did to evaluate how a model can be fine tuned to get your respective, uh, targeted domains data. Yep, Ankita or Kaushik, are you there?
Yes, Rajiv.
Yeah.
Uh, Thanks a lot, Rajiv, for the session. Now, for the learners, if this topic got you thinking about building or using fine-tuned LMS in your own projects, you can check out our live instructor-led programs on springpeople.com. If the listed schedules don't work for you, we also support private training and other flexible learning options. For any details, you can reach to us at training@springpeople.com. Now let's move on to the Q&A session. Over to you again, Rajiv. Attendees, if you have any questions, please raise your hands so we can unmute you so we can ask your questions if you have any. Okay, looks like everything is clear to everyone pretty much. So nobody has any questions. Thank you everyone for joining us today. Now we'll be sharing the session recording with you shortly over email. Before you leave, please take a minute to share your feedback. It will really help us improve future sessions. That's from us today. Have a great learning, and we hope to see you again in another Spring People session soon. Bye.